In 2006, we kicked Pluto out of the Planet Club and called it a worthless rock. Then we actually went there, and what we found made us look like fools because Pluto wasn't dead, it was alive, and it's been hiding something that could change everything we know about life in our solar system. But before I tell you what that is, you need to understand just how insane it was to even attempt this mission. Pluto is 3 billion miles away from Earth. That's not a distance your brain can really comprehend. So let me put it this way. If you got in your car right now and started driving toward Pluto at highway speed, never stopping for gas, never sleeping, just driving straight through, it would take you 6,000 years to get there. 6,000 years. That's longer than recorded human history. NASA didn't have 6,000 years, so they built something extraordinary. A piano-sized probe called New Horizons. When it launched in 2006, it was moving at 36,000 miles per hour, fast enough to cross the entire United States in 4 minutes. It passed the moon in just 9 hours. For comparison, the Apollo astronauts took 3 full days to make that same trip. New Horizons was the fastest object humanity had ever launched into space. But even at that blistering speed, the journey took 9.5 years. Think about that. 9.5 years sailing through empty space. For most of that time, the probe was essentially asleep, hibernating in the darkness, just drifting further and further from the sun. And during those 9 years, something happened back on Earth. The world lost interest. In 2006, scientists held a vote and redefined what it means to be a planet. And suddenly, Pluto didn't qualify anymore. It got demoted to dwarf planet status. People started asking, why are we spending hundreds of millions of dollars to visit a world that isn't even a real planet anymore? But New Horizons kept going. It had no choice. There's no turning around in space. And on July 14th, 2015, after nearly a decade of waiting, the probe finally arrived. It screamed past Pluto at almost 30,000 miles per hour. So fast that it only had a few hours to take pictures before disappearing back into the darkness forever. There was no slowing down, no orbiting, no second chances. It was a one-shot deal. When that first high-resolution image finally appeared on screens at NASA Mission Control, the room went silent. Because what they were looking at wasn't anything like what they expected. It wasn't a gray, cratered, dead world like our moon. It had colors. It had textures. It had features that looked almost geological, almost alive. And right there in the center of the image, staring back at humanity like a cosmic emoji, was a giant, perfect white heart. Welcome to the Curiosity Beast. What I'm about to show you will completely change how you see the outer solar system. Because that heart, it's not just a shape, it's beating. Let's go. That heart isn't just a cute coincidence. It's the key to understanding why Pluto is so utterly bizarre. Scientists named this region Tomball Regio after the astronomer who discovered Pluto in 1930. But the really interesting part isn't the whole heart. It's the left side. Sputnik Planitia. This area is enormous, roughly the size of Texas, and it is one of the strangest geological features in the entire solar system. Here's the observation that made scientists lose their minds. Sputnik Planitia is completely smooth, and I mean completely. No craters, not a single one. Now, if you know anything about space, you know that's weird. That's really weird. Pluto sits in the Kuiper Belt, which is basically the junkyard of the solar system. Everything out there gets pummeled constantly. Look at our moon, and you'll see it's covered in impact craters from 4 billion years of getting hit. But Sputnik Planitia, perfectly smooth, which means only one thing. The surface is young, like geologically newborn. We're talking less than 10 million years old, which in space-time is basically yesterday. Something is actively erasing the craters. The surface is being renewed, repaved, regenerated. But here's the puzzle. Pluto is minus 400 degrees Fahrenheit. At that temperature, water ice is as hard as granite. Rock is frozen completely solid. Nothing should be moving. Nothing should be flowing. So what's going on? The answer is nitrogen. On Earth, nitrogen is a gas. It's what makes up most of the air you're breathing right now. But on Pluto, it's so cold that nitrogen freezes solid. It becomes a glacier. But here's the twist that changes everything. Even though it's solid, nitrogen ice is soft. It's pliable, It flows like extremely thick honey. And underneath Sputnik Planitia, there's a heat source. That heat warms the nitrogen ice from below. The warmed ice becomes even softer, and it rises up through the colder ice above it, like a blob in a lava lamp rising to the top. When it reaches the surface, it spreads out, cools down in the freezing vacuum of sinks back down again. It's a convection cycle, exactly like what happens when you heat a pot of oatmeal on the stove. The hot oatmeal at the bottom bubbles up, spreads across the top, cools, and sinks back down. That's happening on Pluto, but on an absolutely massive scale. If you look closely at images of Sputnik Planitia, you can actually see the pattern. The surface is covered in these giant polygon shapes, each one 10 to 20 miles across. Those polygons are the tops of convection cells. The center of each polygon is fresh, warm nitrogen ice rising up from below, and the edges are the cold ice sinking back down. This means the surface is constantly recycling itself. If an asteroid smashes into Sputnik Planitia and leaves a crater, that crater slowly gets filled in as the ice beneath it continues to churn and flow. Within a few million years, the crater disappears completely. The heart isn't just a feature on Pluto's surface. It's literally alive, in a geological sense. It's circulating, pumping nitrogen around the dwarf planet, constantly renewing itself. The heart is beating. Drop a comment right now. Did you know Pluto had a beating heart? Because what I'm about to tell you next is even more insane. If you think flowing nitrogen ice is strange, wait until I tell you about the mountains. Because on Pluto, some mountains don't just sit there, they explode. We have volcanoes on Earth. They're hot. They spew molten rock at temperatures over 2,000 degrees. They can bury entire cities under ash and lava. Pluto has volcanoes too, but they're nothing like ours. They're the opposite of everything a volcano should be. They're ice volcanoes, cryovolcanoes. New Horizons spotted two massive dome-shaped mountains near the edge of Sputnik Planitia. One of them is called Right Mons, and it's a beast. It's about 90 miles wide at the base and rises about 2.5 miles high. That's comparable in size to Mauna Loa in Hawaii, which is the largest volcano on Earth by volume. But Right Mons doesn't have a sharp peak Instead, it has a giant hole in the center, a depression called a caldera. For years, scientists argued about what they were looking at. Was this actually a volcano, or just a weird impact crater? In 2022, researchers finally settled the debate. They analyzed the terrain and noticed something crucial. The sides of Right Mons aren't smooth like regular mountains. They're lumpy and hummocky, covered in mounds and bumps that look like material that flowed out and then piled up. This is the signature of volcanic activity. Right Mons is a cryovolcano, and instead of erupting lava, it erupts a slushy mixture of water ice, ammonia, and methane. It's not fire, it's the opposite. It's frozen slush, cosmic antifreeze. When this material erupts, it oozes out onto the surface like glacial sludge. It flows for a bit, covering the landscape, and then, because it's exposed to space, it freezes rock solid. But here's the part that shouldn't make sense. Volcanoes need energy. They need heat. On Earth, we have volcanoes because our planet has a molten iron core that's still radiating heat from when the planet formed 4.5 billion years ago. But Pluto is tiny. It's smaller than Earth's moon. And according to everything we know about planetary science, a body that small should have cooled off completely billions of years ago. It should be a frozen, dead, solid ball of rock and ice with no internal heat left. So where is the energy coming from? The leading theory is radioactive decay. Deep inside Pluto's rocky core, there are radioactive elements like uranium, thorium, and potassium. These elements slowly break down over time, releasing energy in the form of heat. It's like having a tiny nuclear reactor buried in the center of the planet. This heat has been slowly radiating outward for billions of years, keeping the interior of Pluto just warm enough to melt the icy layers above the core. The result? A slushy layer of water, ammonia, and methane that occasionally finds cracks in the surface and erupts, building these massive cryovolcanic domes. But this internal heat doesn't just power volcanoes, it's creating something even more shocking. Before we get to that, hit that subscribe button, because what I'm about to reveal is the most mind-blowing part of this entire story. After New Horizons flew past Pluto, it did something incredibly smart. The probe turned around and pointed its camera back toward the sun, using Pluto itself to block the sun's glare. It created an artificial eclipse. And in that moment of shadow, the spacecraft could see something almost impossible to detect otherwise: Pluto's atmosphere. And when the images came back to Earth, scientists saw something that made them do a double take. The atmosphere was glowing. And the color of that glow? Blue. Pluto has blue skies, just like Earth. If you were standing on the surface of Pluto in a spacesuit, looking up at the sun, which would appear as just an extremely bright star, you would see a faint blue haze surrounding you. The sky would glow with this ghostly, ethereal blue light. But don't take your helmet off, because while the sky might look similar to Earth's, the reason it's blue is completely different, and the chemistry happening up there is absolutely wild. On Earth, the sky is blue because of Rayleigh scattering. Air molecules scatter blue wavelengths of sunlight more than red wavelengths. But Pluto's atmosphere is almost unimaginably thin, about 100,000 times less dense than Earth's atmosphere. There aren't enough nitrogen molecules to create that scattering effect. So why is the sky blue? The answer is hazes, specifically tiny particles of organic compounds called tholins. Here's how it works. Pluto's thin atmosphere is mostly nitrogen gas with a small amount of methane mixed in. High up in the atmosphere, ultraviolet radiation from the sun hits those methane molecules and rips them apart. Those atoms then collide with each other and stick together in weird and complex ways, forming long chains of hydrocarbons. These are organic molecules, the building blocks of chemistry that eventually leads to life. And when enough of these molecules cluster together, they form tiny solid particles, tholins, that float in the atmosphere like smog. These tholin particles scatter blue light, just like air molecules do on Earth. That's what creates the blue glow. But here's where it gets even stranger. These particles don't just float forever. Gravity pulls them down. They fall. It's like snow. But instead of frozen water, it's frozen organic compounds drifting down through the atmosphere. And when this organic snow finally lands on the surface, it doesn't stay blue. Exposure to radiation causes a chemical reaction. The tholins darken. They turn deep red, almost brown. This explains one of the most visually striking features on Pluto. Right next to the bright white heart, there's a massive dark red region that looks like a blood stain on the surface. Scientists named it Cthulhu Macula, after the cosmic horror monster, because it's dark, it's ominous, and it covers a huge area. But it's not made of rock. It's made of billions of years of accumulated tholin snow. It's organic gunk, layer upon layer of it, coating the ice in a thick blanket of reddish-brown tar. So Pluto has blue skies, red snow, and a white beating heart. It's remarkably colorful for a world that's supposed to be a dull, gray, frozen rock. But as visually stunning as all of this is, none of it compares to what scientists think is hiding beneath the ice. The idea of liquid water on Pluto sounds absurd. This is a world that's 3 billion miles from the sun. The surface temperature is minus 400 degrees Fahrenheit. Water at that temperature should be frozen harder than steel. How could there possibly be liquid water anywhere on this frozen wasteland? But the evidence is hiding in plain sight, written across the surface in giant cracks and fractures. When New Horizons mapped Pluto, it saw massive canyons running across the surface, some of them hundreds of miles long and several miles deep. These aren't impact scars. They're tectonic features, cracks in the crust, and they look exactly like what happens when you freeze a water balloon. As water freezes, it expands. If you've ever left a bottle of water in the freezer too long, you know this. The ice takes up more space than the liquid did, and the bottle cracks or bursts. NASA scientists think the same thing is happening to Pluto, but on a planetary scale. The crust is cracking because something underneath is freezing and expanding. The only thing that makes sense is a subsurface ocean. Sometime in Pluto's past, there was liquid water beneath the crust. Over billions of years, that ocean has been slowly freezing from the outside in. As the water turns to ice, it expands, pushing outward against the crust and cracking it open. But here's the thing. If the ocean had frozen completely, the cracking would have stopped billions of years ago. The fact that we still see relatively fresh-looking fractures suggests the freezing process is still happening, which means there's still liquid water down there. But wait, There's more. Remember Sputnik Planitia? That giant smooth heart-shaped basin? That feature is a massive weight on the surface of Pluto. And all that weight is sitting on one side of the planet. Because of physics, that weight should have caused Pluto to tip over. The heavy side should have rotated toward the equator to balance out the mass distribution. But Pluto didn't tip all the way. Sputnik Planitia is sitting in a weird position, almost like the planet started to reorient itself, but then stopped halfway. The only way that makes sense is if there's something under Sputnik Planitia acting as a counterweight. And the only thing that could do that is liquid water. A subsurface ocean directly beneath the heart, providing just enough extra mass to balance out the weight of the ice above. So the theory goes like this. Beneath Pluto's frozen crust, maybe 50 to 100 miles down, there's a layer of liquid water. This ocean is probably incredibly salty, maybe as salty as the Dead Sea, because salt lowers the freezing point of water. And it's mixed with ammonia, which acts like antifreeze, keeping the water liquid even at temperatures far below what would normally freeze pure water. This ocean is in direct contact with Pluto's rocky core, which is still warm from radioactive decay. That warmth keeps the bottom of the ocean from freezing solid. Now here's why this matters. On Earth, wherever we find liquid water, wherever we find energy, and wherever we find organic chemistry, we find life. It doesn't matter if it's a scalding hot volcanic vent at the bottom of the ocean or a freezing lake trapped under miles of Antarctic ice. Life finds a way. Pluto has all three of those ingredients. It has liquid water in the subsurface ocean. It has energy from radioactive decay in the core. And it has organic compounds, those tholins, raining down from the sky. Could there be microbial life swimming in the dark, salty, ammonia-rich ocean of Pluto? We don't know. We have no way of knowing without going back and drilling through 100 miles of ice, which is far beyond our current technology. But the fact that we even have to ask the question is staggering. This was supposed to be a dead world, a frozen relic, a cosmic afterthought. Instead, it might be one of the best candidates for finding life beyond Earth, joining the ranks of Europa, Enceladus, and Titan. And we almost didn't go there. We almost decided Pluto wasn't worth the trip. So there you have it. Pluto, the dwarf planet we kicked out of the club. The frozen rock 3 billion miles from the sun. It has a beating heart of flowing nitrogen ice. It has erupting ice volcanoes. It has blue skies and red organic snow. And it might have an ocean beneath its surface harboring life. We were wrong about Pluto. Completely and utterly wrong. And that should make you wonder, what else are we wrong about? What other worlds in our solar system are we dismissing as dead and boring when they might actually be teeming with secrets? So what do you think? Could there be life on Pluto? Let me know in the comments. And if you made it this far, thank you. Smash that like button, share this with anyone who loves space mysteries, and subscribe to the Curiosity Beast, because the universe is full of secrets, and we're just getting started uncovering them. See you in the next one. Stay curious.